Hello everyone, my name is Jyoti Pandey. I am Assistant Professor in BCA Department in IIMT College of Management. Today I am going to explain the topic stack in data structure. So before going into detail, first of all we should know that what is data structure or what is stack. A stack is widely used linear data structure in modern computer in which insertion and deletion of an element can occur only at one end, that is top of stack. It is used in all those applications in which data must be stored and retrieved in the last. So what it means? It means that stack is a linear data structure, or we can say it is a non-primitive data structure in which if we want to insert any element or if we want to delete any element, so these two operations will be done from the top of the stack, that is a single pointer. An everyday analogy of stack data structure is a stack of books on a desk, stack of plates, table tennis, stack of uh, bottles, undo or redo mechanism in the text editors. So here are some pictures of stack, real life examples of stack. First is a stack of coins, stack of plates, stack of tennis balls, stack of books. If we want to remove, if we want to take a coin, so first what we will do, we will take first coin. We will take last coin, which we insert at the last. So the concept of stack is based on LIFO. It means whatever the order of the insertion is given, we have to first insert the element, and if we want to remove those elements, so uh, that element which has inserted at the last will be removed first. So stack is a data structure in which all insertion and deletion of entries is made at one end called top of the stack. So top of the stack is a pointer through which we can either insert the element or we can either delete the element or remove the element. The last entry which is inserted in the first one, that will be removed. So as I told earlier that the concept of stack is based on LIFO. It means last element which we have inserted, if we want to remove, then first that element will be removed which has entered in the last position. Some key points related to stack. It is called stack because it behaves like a real word stack. Piles of book. If we want to take one book, then whatever the book we have inserted first, we will take it at the last. A stack is an abstract data type with a predefined capacity, which means that it can store the elements of limited size. It is a data structure that follows some order to insert and delete the elements, and the order can be LIFO or FIFO. Here is the representation of stack. As we can see that there is a stack, how these operations are performed. Here, as you can see that a word is written, that is push and pop. What it means? It means if you want to insert any element in the stack, then this operation is known as push operation. And if you want to remove some element from that stack, then this operation is known as pop operation. So there is in first picture stack, there is a stack and the operation push is performing. So all the data is inserting in push operation. And the concept is based on last in first out, that is LIFO. And if we want to pop element, if we want to remove the element, that operation is known as pop operation. So which element has entered at the last, that will be removed first. So stack can be implemented by means of array, structure, pointer, and linked list. Stack can be either be a fixed size or dynamic. As I discussed, there are some operations. First one is push operation, pop operation, top, clear, empty, sign. So push operation, as I told earlier, that it means to add element into the stack. If we want to add element in the stack, or if we want to insert element in the stack, then this operation is known as push operation. And if we want to remove top item from the stack, then this operation is known as pop operation. And the top, it is a pointer through which we can either insert the element or through which we can either remove the element. Is empty is the condition which I will discuss later. So in this picture, as we can see, there are elements are pushing. It means elements are inserting. And when all the elements has inserted, then the pointer value define that which is the last element which has inserted. And now if we want to remove those elements, we will perform pop operation. A basic operation of stacks. For stacks, create a stack, leaving it empty. It means whenever we create a stack, there is no element in the stack. So what we have to do? Test whether the stack is empty. First, we have to check either our stack is empty or full. Test whether the stack is full. As I said, return the size, number of entries of the stack. It means how many elements have you inserted in the stack. Retrieve the top entry from the stack provided the stack is not empty. Pop the entry of the top of the stack provided the stack is not empty. Push a new entry onto the top of the stack provided that the stack is not full, and print all the entries of the stacks. So as you can see in this picture, I am going to explain how push operation and pop operation has worked in stack. So here as you can see, the first element A has inserted in the stack. It means push box A onto the stack. Means one element has inserted in the stack, that is A. Again, a second element has also inserted in the stack. So we can say push box B onto the stack. It means push operation is performing. Now, as you can see, pop a box from the stack. It means topmost element now has popped, or we can see has removed from the stack. And now A is remaining. So again, when we perform pop operation, again that A element also removed from the stack. Now stack is empty. Again, we have put push box C onto the stack, and now box D onto the stack, and now box E onto the stack. So this is how push and pop operation are working in the stack. So as you can understand that when we want to insert the element, then all the element which we are inserting is known as we are performing push operation. And when we want when we remove topmost element from that stack, then this operation is known as pop operation. So how we can create a stack? As you can see here, we use a constructor to initialize a new created stack as empty. As you can see in this picture, there is a stack, and we have created a constructor same name as a stack, or we can create a stack here. Here are entries, index number 0, index number 1, index number 2, and at the last maximum length -1, because length has started from the 0. Push operation. Now I will explain the push operation in detail. First of all, when we perform the push operation, what are the rules which we have to follow? First, before inserting an element in the stack, we check whether the stack is full. It means, first of all, when we are going to perform push operation, we have to check whether the stack is full. Means if there is any space for inserting or not. If there is no space in the stack, then this condition is known as stack full, or we can say overflow condition. It is mentioned in second point. If we try to insert an element in a stack and the stack is full, then the overflow condition occurs. Okay, so what are the results of these these 2 points? Means if we want to insert or if we want to perform push operation, first of all we have to check that stack is full. Means there are some space to insert new element. If there is no space in the stack to insert new element, it means this condition is known as a stack flow, or we can say stack overflow. If overflow is not occur, then when we initialize a stack, a set of value of top as -1 to check that stack is empty. Means if there is no overflow condition, then stack will be empty. And if the value of top is equal to -1, it shows that our stack is empty. When the new element is pushed in the stack, first the value of the top gets incremented. Whenever we want to insert a new element into the stack, then the value of top pointer, that is top of the stack, will be incremented by 1. The elements will be inserted until we reach the max size of the stack. Definitely, if we want to insert the element, then these elements will be inserted until we didn't get the max size condition. So here we can see from the example, there is a starting value of top that is -1. It means our stack is empty. We insert first element, then the value of top will be incremented by 1, and the now value of top is equal to 0. Again, when we are going to insert next element, that is 20, the value of top is equal to 1. Again, we are pushing next element, that is 30, value of top is equal to 2. Again, we are pushing the value of 40 and the top value is equal to 3. Now our stack is full. At this condition, if we want to insert new element, then we cannot insert because our stack is full, and this condition, as I described earlier, this condition is known as stack full. Now pop operation. These are the steps involved in the pop operation. Before deleting the element from the stack, we check whether the stack is empty. Now, as we have checked the condition of overflow in the insertion or in the push operation, similarly, we have to check condition of stack empty in pop operation. Means if we want to delete some element. So first we have to check, is there any element in the stack? If there is no element in the stack, then what we will delete? What we will remove actually? So this condition is known as stack underflow condition. So if the stack is not empty, we first access the element which is pointed by the top. If the stack is empty and we want to remove, or we can say we want to apply pop operation, then this condition is known as underflow condition. If the stack is not empty, then first we have to access the element which is pointed by the top. Definitely, we will remove only that element which is pointed by the top. Once the pop operation is performed, the top is decremented by -1. It means after every deletion, top is decremented by 1. So here, as we can see, these are the how pop operation has worked. First of all, our stack is full and the value of top is equal to 3. It means we have 4 elements in our stack. So our at index number 3, top is pointing the element 40. When we remove or when we pop that 40 element, then the value of top is equal to 3. Again, when we pop element 30, then the value of top is equal to -1. When we pop the element 20, value of top is equal to 0. When we pop the element 10, then the value of top is equal to -1. And if the value of top is equal to -1, it means our stack is empty. Here is the working of stack. A pointer called TOP, top of the stack, is used to keep track of the top of the element in the stack. When initializing the stack, we set its value to -1 so that we can check if the stack is empty or comparing top is equal to -1. On pushing an element, we increase the value of top and place the new element in the position pointed by the top. On popping element, we return the element pointed by top and reduce its value. Before pushing, we check if the stack is already full. Before popping, we have to check if our stack is already empty. As you can see, first our stack is empty and the value of top is equal to -1. Then we insert first element, value of stack 0 is equal to 1 and the value of top is equal to 0. Again, we are inserting 2, again 3. So value of top is equal to 2. And now when we start pop operation, the value of top is decremented by 1. Application of stack, we can use stack in balancing of a symbol mainly. And as we know, each program has an opening and closing braces. When the opening braces come, we push the braces in the stack, and when the closing braces appear, we pop the opening braces from the stack. Therefore, the net value comes out to be 0. If any symbol is left in the stack, it means the sum syntax occurs in the program. And we are most of the time we use stack in string reversal. As we can see in the picture, when we in the order of insertion is just reverse the order of removal. Means when we push the element in which order, we cannot pop element on the same order. So stack is also used for reversing a string. If we want to reverse a string, so we can achieve this with the help of stack. We push all the characters of string in a stack until we reach the null character. After pushing all the characters, we start taking out the character one by one until we reach the bottom of the stack. We can use the stack in undo and redo. It can also be used for performing undo redo operations. For example, we have an editor in which we write A, then B, and then C. Therefore, the text written in editor is ABC. So there are three states A, AB, and ABC, which are stored in the stack. There would be two stacks in which one stack shows state and the other shows redo state. If we want to perform undo operation and want to achieve AB state, then we implement pop operation. Recursion and the next application of stack is recursion. Recursion means that the function is calling itself again and again. Recursion in C, as most of the students or members have studied in C programming, the recursion means when a function calls itself again and again. To maintain the previous states, the compiler creates a system stack in which all the previous records of the function are maintained. Now, how arithmetic expression can be evaluated through the help of stack. So stack is very effective data structure for evaluating arithmetic expressions in programming language. So what we have in any arithmetic expression? In any arithmetic expression, we have operand and operators. In addition to operand and operators, the arithmetic expression may also include parentheses like left parenthesis and right parenthesis. So there are some operators and their associativity and precedence. So first is the exponential operators. Its precedent is the highest, followed by multiplication and division, and its associativity is from right to left. Similarly, next operator is multiplication and division. Its highest, followed by addition and subtraction, and its associativity is left to right. And next one is addition and subtraction. Its precedence is lower in comparison of above two, and its associativity is left to right. There are two steps of evaluating any arithmetic expressions. First, convert the given expression into special notations. Evaluate the expression in the new notations. Notations for arithmetic expression. There are three notations to represent an arithmetic expression: infix notations, prefix notations, and postfix notations. So what is infix, prefix, and postfix notation? In infix notation, if operator is between the operand, as an example, we can see there is A plus B. So this is known as infix notation. And if the operator is before the operand, like we can see in the example plus AB or minus CD, so it is known as prefix notation. And similarly, if the operand is after the operator, so it is known as postfix notations. How we can convert infix notation to prefix and postfix? As we can see here, in the first one is infix notation, A multiplied by B. As I discussed earlier, that prefix notation is when operator is before the operand. So multiply AB. And postfix notation means when operator are after the operands. There is an algorithm to convert infix notation to postfix and notation. So as you can see, this algorithm is explaining here. First of all, what we have to do, we have to push onto the stack and add to the end of the x. What is x? X is an arithmetic expression written in infix form. Means what we are doing in this algorithm, we are just converting the infix expression into its postfix expression. So we will now what we will do, we will scan x from left to right and repeat step 3 to 6 from each element of x until that our stack is empty. If an operand is encountered, add it to y. If a left parenthesis is encountered, push it onto stack. If an operator is encountered, then repeatedly pop from the stack and add to y each operator which has the same precedent or higher precedent than operator. Add operator to the stack. If a right parenthesis is encountered, then repeatedly pop from the stack and add to y each operator until a left parenthesis is encountered. Remove the left parenthesis. So here is the example how we can convert an expression that is in infix form, and we are going to convert with that algorithm to its postfix form. Here are the symbols which we are going symbols, and those symbols we are scanning from left to right. We are, whatever the parenthesis and operator we are going to push into the stack, and what we are getting after converting into postfix expression, this is explained in this algorithm or in this example. Now, as we convert the infix expression into postfix expression, similarly, we can convert the infix expression to prefix expression. In prefix of expression, what we will do, we will put that operator before the operator. So this is all about stack, and thank you so much.